Hello, let's continue our Sudoku adventure with Taco Cat by Gene. So we have normal 6 by 6 Sudoku rules. That means in each row, each column, and each 2 by 3 box, we are placing the digits 1 to 6 exactly once each. We also have sandwich sums in the grid. That's these digits outside the grid, but they're a little bit special, so definitely pay attention to this. What you need to do is, so say this 6 here. What you need to do is you need to locate the 1 and the 6 somewhere in the column, right? The 1 and 6 will be somewhere in the column. In between that 1 and 6, we need our values to sum to the clue outside. So maybe 2 plus 4 would work. But be careful because there are copycat cells. So there's exactly 6 copycat cells somewhere in the grid. Each row, each column, and each box contains 1 copycat cell. So once we have a copycat cell, let's say this was a copycat cell, the rest of the row, the rest of the column, and the rest of the box would be guaranteed not a copycat cell. We'd have one, so that gives us 6, 1 per row, 1 per column, 1 per box. Additionally, the digits 1 to 6 appear once and only once within each copycat cell. So if this was a copycat cell and it was a 3, then none of the other 5 copycat cells are allowed to have a 3 in them. All right. Now, digits in a copycat cell count as the digit rotationally opposite them, though the digits being summoned are always between the actual digits 1 to 6. So for example, if row 2, column 1 is a copycat cell, and it contains the digit 5, that digit 5 doesn't actually matter to us because what we want to do is we want to go to the rotationally opposite cell. So if we were to rotate 180 degrees, we would end up in row 5, column 6. So row 2, column 1, you rotate 180. If you were to literally put this on a sheet of paper and turn it upside down, you would end up, it would be this cell here. This would be row 2, column 1 if we're upside down. Now this cell might have a 3 in it. And so for the purpose of sandwich clues, this copycat cell would have the value of 3, not 5. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so looking at this, there's some impossible sandwich sums, right? That normally would be impossible. Like you can't have a 1 in between the 1 and 6. However, we can in this, which means that the copycat cell in this column is between the 1 and the 6, meaning I'm going to use gray for not copycat and green for copycat. So these cannot be copycat cells because they need to be in between the 1 and the 6. The 18 is too big. Normally, if I had a 1-6 pair here, these would add to 14. Why do I know that? Well, the whole row adds to 21. 1 plus 6 is 7. 21 minus 7 is 14. So that means that we need a copycat cell somewhere. Well, our copycat cell, sorry, this doesn't have to be 1-6 pair necessarily. I don't think, not yet. Somewhere there's a copycat cell that increases us by at least 4 inside of the sandwich sum. That's, I guess, what I'm trying to say. And so I think it would have to be a 2 replaced with a 6. That's the only way to increase by 4 because we're not putting a 1 in between our sandwich. And so there's going to be a 2 in between inside of our sandwich, and it's going to be replaced with a 6 that just gets us to 18, which actually means that these are not the copycat cells and they are a 1-6 pair. And so that means that this is the other 1-6, and this is a copycat cell, which points at a 1. We don't know what it points at this cell, which actually must be a 1. There we go. Okay. And so that's 6, that's 1, that's 6, and this is whatever it wants to be because it's a copycat. Now, the rest of the row, the rest of the column, and the rest of the box cannot be copycat, which means one of these two is. So one of these two is the 2. It's the thing getting copied to a 6, which means that there's a 6 either here or here, which means there's a 6 one of these two. Because whichever one of these is copycat, it's going to rotate to either here or this rotates to here. And it has to find a 6 there, as we discussed earlier. Now, in between here, this needs to sum to 15. That's also impossible. If this were a 2, we're going to minimize this. If this were a 2, then these would sum to 12. So we need to increase by 3. But if this is a 2, the minimum I could have is a 3. So I think, so if this was a 3 though, then these would add to 11, which means we need to add 4. So we'd have to do the 2 replaced with a 6. So basically, the copycat cell that's in one of these two points at a 6, but we already know the rotational opposites are here and that we already have the 6. So this has to be our copycat cell. I believe it could be a 2 or a 3. I don't think it can be a 4. Oh no, sorry. The 3 would point to a 6, the 2 points. That's interesting how that works. Would the 4 point to a 6 if we had a... I'm not sure. I'm not going to put a digit in here yet, but it points at this one and it gets replaced with a 6. And, well, that means that these two add to 9. They can't be 3, 6. They have to be 4, 5. Yeah. So basically, that's what I was seeing, is that this is a 4, 5 pair, and then this is a 2, 3 pair. But we don't actually know whether this is a 2 or a 3, because it actually works out either way. Yes. Okay, so this row, this column, and this box are all gray. Okay, getting there. So we just have this 6. Is there anything else to look at here? So we don't really care what goes in this copycat. It's interesting. The only thing we've got left is this 6. So we know that we don't start here. Neither of these are 1. This isn't 1, so the 1's one of these. Okay, so what I can rule out is having a copycat cell as the only cell in between a 1, 6 pair, because there's nowhere to put a 1. Oh, no, wait, I can put a 1, 6 pair here. Never mind. Okay, if this was a 1, 6 pair, this would be 6, this would be 1. Oh, no, sorry. This cell can't be 1 or 6, so it cannot be a sandwich end. Can't be 1, and we have the 6's cornered. Okay, so this isn't a 1 or a 6. And none of these are... Yeah, so the only cell that I could surround with a 1, 6 pair was this one. That could still be a copycat. But we know that doesn't happen because this can't be 1 or 6. So, therefore, we are not just pointing at a 6 alone. Now, what's interesting is we could do a 3 cell, and that would be very interesting if we did a 3 cell sandwich. Now we know this isn't 1, 6 and this isn't 1, 6. So actually, right, I think we have to make this 1, 6. Okay, never mind. That's much simpler. Why? Because we can't do it in 1 cell. We can't add to 6 in 1 cell. So we need to do at least 2 cells. But since this can't be a sandwich end, this can't be a sandwich end, these have to be the sandwich ends in order to have 2 in between. And that makes this 1 and that 6. Okay. Now, we know that neither of these are a copycat cell, so the only way we're going to be adding to 6 is 2 plus 4. Because we can't do 1 plus 5. The 1 is gone. And that conveniently places this 2, which we know is our copycat now. And that rotates over here, giving us the 6 that we needed. All right. So this is a 3, 5 pair. In fact, this is just 3, 4, 5. The 4 is up here. So 4 is down here. This is also 3, 4, 5. Oh, 2, 4 pair gives us the 5 here. That's 4. Okay. Oh, right. We can gray out the rest of these because we placed this copycat 2. Now that we have a copycat 2, this cannot be a copycat 2, so this is a 3. Since you can't repeat digits in the copycat cells. Now, we need a 2 down here, but it's not in our copycat cell. So the 2 is in one of those 2. So this is from 3 or 5. It cannot be the 6. So this is actually a 2, 6 pair. Oh, and that can't be the 6 either. So that's 2 and that's 6. Handy. This is a pair as well. This is 1, 6. So we know the order. That's 1, that's 6. This is 3, 4, 5. 4 is down here. All right. Well, 3 is already copycat, so we have to make this 5, which makes that 3 and that 5. All right. That makes this a 3. These are not 3s. Okay. So we know that all threes have to be gray because we already have a 3 that is copied. We do not have a 6 that's copied yet. Oh, this box needs 1, so now 6 is copied. So this is a copycat cell, and this is a copycat cell. And the 2 digits left are the 1 and the 4. This can't be the 1, so this is 4 and this is 1. That gives us 2 and 4 here. That gives us 3 and 4 here. Row finishes with a 3. These are from 1, 2, and 5. So that has to be 2. That has to be 5. That has to be 1. This is a 4 or 5, but sees the 5. So that's 4, 5, and 4. And we need a 2, we need a 5, and we need a 3. Okay. Neat puzzle, Gene. Very cool rule set, actually. And I have no idea how you set this, because, yeah, that's difficult. But very neat. Quite enjoyed that. Let me know how you did, and if you enjoyed this one, leave a like, subscribe, and a kind comment below.